Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of exponential regression. This is standard A.9E in the great state of Texas, and we are using item number 43 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a student dropping a ball and measuring the height when it bounces. So the number of bounces, we see that it is going to be decreasing. So 0 bounces, we're starting at that 72 inches, and then it bounces only to 43, bounces again. And you can just kind of see that ball getting lower and lower as it continues to bounce. It's losing some of its energy. So we need an exponential function that best models is real world data. And so first we need to understand what is our standard form for exponential functions. And if we look in our reference materials, we are not going to find it. We are going to find factoring, properties of exponents, and we get linear equations, and then we get quadratic equations. We get no exponential functions. So we need to come into this test knowing that our standard form is going to be y equals a times b to the x. And whereas we have a is our initial value or our principal if you're dealing with money and investing and what type of interest you might use, whether you're compounding it or not. And then this is going to be our rate. Could be a growth rate, could be a decay rate, depending on, in this case, it's going to be decay rate because it is getting smaller and smaller and smaller. Now, we don't have to do this manually. We can actually use the calculator for this, but we do need this initial function. So let's go ahead and open up a calculator. And we can do either one. Let's do Desmos here. And what we need is we're going to first need to go ahead and just insert our table of values. And let's get that here first. So we're going to add a table. And you notice they are labeled as x sub 1 and y sub 1. That's going to be important for us in just a moment. So you can either go side to side. I'm just going to go down 0, 1, 2, 3, 4. Then I'm going to go over to my y's. Now what we want to do is we want to go ahead and make sure that we are typing these in exactly. So 43.2, if you mismatch these, obviously, you're going to have some errors. So 15.6, and then we've got 9.3. So let's just take a look at what we have here. And this is discrete at this point. We want an exponential function so we can make it more continuous. But you see here, we've got that initial value right here, and you see it is starting to slope just a little bit like it would curve down this way. But we need more data. Like I wish they would give us more 5, 6, 7, 8, 9. Okay. So what we do next here is going to be key. We are going to take our standard form here. Remember, this is the y equals a times b to the x, but we need to be very specific. Okay. So the y is not just y. The y is our y sub 1 because that's what we're using in here. So we're going to do y sub 1. And instead of the equals, in order to graph this as linear regression, what we need is we need that tilde sign. So that's that little squiggle, and you have to hold the shift, and then on most keyboards, it's going to be that key right above the tab and right to the left of the 1. And then we're going to do a times b, and then we need to get into the exponents, x, but not just x, it's going to be x sub 1. So we replace the equal sign with the tilde, and then replace the y with the y sub 1, the x with s sub 1, and now we're good to go. So look, now we've got our linear or exponential function right here, and more importantly, look at what we have. We've got an a value of 72. So y equals 72.0, and then we've got a b value of 0.599. Let's call that 0.6 to the x. All right, let's see which one best matches that. And you see it's going to be A. So that is our answer.